In this video, we'll talk about how chemical equilibrium systems respond to stresses. This idea is called the Châtelier's principle. We'll only focus on one stress in this video, a change in concentration. By the end of this video, we should be able to predict which way an equilibrium system will shift when there is a concentration stress. I want to go over a very quick recap on one idea about chemical equilibriums before we talk about Le Chatelier's principle. We should already know that a chemical equilibrium is established when the rate of the forward reaction equals the rate of the reverse reaction. Also, if a system is not at equilibrium, then the system will shift towards either the forward direction or the reverse direction in order for it to reach chemical equilibrium. We can visualize this with this nice PhET simulation. This is actually 3 simulations of the same chemical system. In these simulations, the green circles are the reactants, while the red circles are the products. Again, they're the same chemical system. They're just at different points of equilibrium. Right now, none of them are at equilibrium. I'll let the simulation run to let you see how, even though they're at different points of equilibrium, all of them will arrive at the same equilibrium ratio, or in other words, the same equilibrium constant. Constant being the key word here. Here we go. When chemical systems are at equilibrium, there are different things that can be done to the system that temporarily brings them out of equilibrium. These are called stresses. Le Chatelier's principle is a simple idea that if a system at equilibrium is stressed, then the system will shift in a direction that relieves or reduces the stress. 3 types of stresses are covered in chemistry, but I'll just discuss concentration stresses for this video. If you're wondering why there's a roly-poly doll right there, it's because Le Chatelier's principle kind of reminds me of it. If a system at equilibrium is subjected to a stress, then the system will shift in a direction that relieves that stress. Let's take a look at the simulation again and see how changes in concentration will affect an equilibrium system. Right now, the system is at equilibrium, but what happens if we increase the amount of reactants? Try to make a prediction before you actually see it happen. Okay, so again, if we increase the reactants, make a prediction. Here we go. looks like increasing the reactants will cause the equilibrium to shift in the forward direction to reduce the amount of reactants. What happens if we increase the amount of products now? Again, make a prediction. Make a prediction. Okay, here we go. All right. Looks like increasing the products will shift the equilibrium in the reverse direction to reduce the amount of products. Okay, what if we decrease the amount of products now? Again, make a prediction. And hopefully you've made a prediction. Here we go. So, decreasing products will cause the equilibrium to shift in the forward direction to produce more products. Lastly, what if we decrease the amount of reactants this time? Make a prediction. Okay, hopefully you've made a prediction. Here we go. Okay, this one seems like it'll take a while, but it seems like decreasing the reactants will cause the equilibrium to shift in the reverse direction to create more reactants. I hope you're seeing how straightforward the Châtelier's principle is. Again, if there's a stress on the equilibrium system, the equilibrium will just shift in a direction, either towards the products or towards the reactants, in order to relieve that stress. Let's go over a few examples. In this example, the chemical system above is at equilibrium. Predict which direction the chemical system will shift if we increase the amount of FeSCN plus 2. Then predict what color the chemical system would appear more like, more yellow or more red. So if we increase the amount of FeSCN plus 2, that means there's going to be too much product. To relieve that stress, the system will shift in the reverse direction to reduce the amount of products. If it shifts in the reverse direction, the chemical system should look more yellow. This is because shifting in the reverse direction creates more iron 3 ions, which are yellow according to the chemical equation. Take a look at the image below. You can see if this prediction is correct. Okay, not sure if you can see this. This one's kind of hard to see, but when the FeSCN plus 2 solution was added, it was a bit more yellow as it was being added. You can kind of rewind this if you want to see that subtle hint of yellow. Now we're on to example 2. Everything's the same for this problem except the stress is that we increase the amount of SCN minus this time. If we increase the amount of SCN minus, that means there's too much reactants. To relieve this stress, the equilibrium will shift in the forward direction to reduce the amount of reactants. If the system shifts forward, that means the system should appear more red because FeSCN plus 2 is red in color. Let's see if our prediction is true. Yep, example 3 now. Again, everything's the same about this problem except the stress is that we will decrease the amount of Fe plus 3. If we decrease the amount of Fe plus 3, then there's going to be 2 less reactants. This stress will cause the system to shift in the reverse direction to create more reactants. If it shifts in the reverse direction, that means the system should appear more yellow because, again, Fe plus 3 ions is yellow in color. Let's confirm our prediction here. Now look at the image below. In order to actually remove iron 3 ions from the solution, we could put hydroxide ions into the solution. Hydroxide ions will combine with the iron 3 ions to form iron 3 hydroxide. And the thing is, iron 3 hydroxide is insoluble, meaning it will precipitate out of the solution. So the overall effect is that iron ions will be removed from solution by adding hydroxide ions. Okay, let's take a look. And again, our prediction is correct. Go ahead and try this practice. There's going to be 4 different stresses on the equilibrium system described by the chemical equation above. You can figure out, maybe on a piece of scratch paper, what the stress is and which way the equilibrium system will shift as a result of that stress. Pause the video now. I'll give you the answer in about 5 seconds. Okay, so pause the video. And here are the answers. You can go ahead and take a look, compare it to what you wrote. Did you get it correct? If not, you can try to look at the examples that we went over from before. And I will not have more practice for you this time. I'm just going to combine it with the next 2 videos that we will be doing and then give you the practice after that.